Thank you so much for joining us for Ryerson's second Metal 101. My name is Chelsea Hunt, and it's my pleasure to host you on this interactive and immersive journey into the basics of metal. So for the next hour, we're going to dive headfirst into the need-to-know information about aluminum, steel, and stainless products. We're going to cover everything from differences in shapes and forms to the anatomy behind the various grades. And as you can see from the map on your screen, we've created a university experience for you. So our professors are some of the very best and brightest minds in our supply chain, and our curriculum is based on our collective 180-year experience of Ryerson. So let's take a look at our class schedule for today. We're going to spend roughly 15 minutes in each campus, steel, aluminum, and then stainless steel. And then you'll have the opportunity to ask questions at the conclusion of each campus presentation. You can do so by using the Q&A button at the bottom of your screen. It's right next to the chat feature, and we'll try our best to answer them live. And if we don't get to everyone's questions, we will be following up after this presentation to try to answer those for you. So without further ado, class is starting, and we don't want to be late. So Professor Crane, take it away.
Hello, and welcome to the carbon steel portion of Metal 101. I'm Brian Crane, Carbon Flat and Plate Product Manager for Ryerson's West Region. I'd like to thank you for taking the time to be with us today as we learn about the basics of steel. We know your time is important, so thank you for taking the time to be with us. Today we'll cover a range of topics. What is carbon steel? What makes up steel flat products? Next, we'll get into what makes up steel grade. Then we'll move over to the world of long products before we wrap things up with the key takeaways of steel. So let's get started. So what is steel? It's an alloy of iron mixed with other elements. And when it comes to the making and composition of steel, I like to use the analogy of baking a cake. Iron, which makes up the majority of steel, so we can think of that as the flour. Other elements like carbon, manganese, or phosphorus act like the eggs, sugar, and vanilla in our steel recipe. Now that the steel is made, let's work it into shape. Let's discuss the two most frequently called out shapes in steel: sheet, commonly known as coil, or flat roll, and plate. And let's start with sheet. Each product or production step adds certain features and benefits, and it all starts with hot roll. Hot roll black, or sometimes called hot roll dry, is the basic first process steel. This product is meant for end uses where the structural properties of the steel is most important. Think about frames for trucks and other structural applications like that. From hot roll, we can send the coil through a bath of acid to remove scale and any rust that formed during the steelmaking process. After the acid bath, it's coated in oil to protect from rust or any additional corrosion. This improves the surface condition and is a little bit better than hot roll. The next step in the process that we can do is cold roll. Cold roll reduces to a thinner gauge material and tightens up the thickness tolerance and improves its surface condition. This product is best suited for applications where surface finish and cosmetic appearance are important. Think about doorways and metal applications for industrial storage and things like that. Last but not least is our coated product. And here is where we have an excellent video to break down the world of coated steel.
Hey y'all, I'm a hot roll sheet of steel. I'm going to be made into an air duct. But wait, that means I need to become more corrosion resistant. Let's face it, this mill finish simply won't cut it. So I need a bath. What type of bath, you ask? Good question. You see, my level of corrosion resistance will depend on the type of coating I get. For instance, see the one labeled Galvalume? It contains aluminum zinc alloy. That would definitely make me more corrosion resistant, not to mention heat resistant. My cousin, who's now a roof, got one of these baths. Or see galvaniled over there? That's a zinc iron alloy bath. That wouldn't make me as corrosion resistant as Galvalume. I remember my friend, who's now a door, took a galvaniled bath. The good news is my friend can be painted without further surface preparation. But it did create a gray matte appearance. No thank you. This sheet has got to shine. Okay, well here's my bath, galvanized. It's a zinc bath. How much zinc, you ask? Well, that depends on the specified coating weight. The higher the weight, the higher corrosion resistance. Me, I'm going all in. G90. That means 0.9 ounces of zinc coating applied per square foot on both sides. And that means when I'm done, you'll be able to weld me, for me, and if you treat me right, you'll even be able to paint me. Okay, time to hop in.
Excellent. Now that we've explored the world of flat roll, let's move over to plate. What is plate, and how is it that different than sheet? Basically, it all comes down to thickness. 3/16 of an inch thick is the dividing line between plate and sheet. Other ways we mark the difference is the width. Plate usually being a wider width, say 84, 96, 120 inches, or even wider. So let's take a look at this short video for more info. One more thing on plate products that I'd like to introduce you to is that plate products are broken down into two segments, as rolled and heat treated. As rolled is like hot rolled, a product straight off the mill, produced at the desired grade for your end use. Heat treat plate is where the as rolled product is reheated in a furnace and either left to cool in the air, which is called normalizing, or dunked in a bath of oil or water. This process is called quench and temper. These processes are designed to refine grain structure or increase the strength or hardness of the plate, all dependent on the end use. Now that we've talked about what makes plate and sheet different, let's get back to the makeup of steel and learn about grade anatomy. At first glance, it looks like an alphabet soup, letters and numbers mixed around. What does it all mean? Now, the main U.S. organization that writes the many recipes for steel is ASTM, which stands for American Society for Testing and Materials. In metals industry shorthand, the grade will start with an A, followed by numbers, and in some instances, maybe more letters. In the majority of grades, the number behind the A gives us one of the mechanical properties of the grade. Let's use A36 as our first example. A36 is the most common, vanilla size and basic grade of steel. But let's break it down. A is for steel, and 36 indicates a 36,000 PSI min yield strength. Another common grade used a lot in structural applications is A572-50. 572 being the number assigned to it by engineers, and the last two digits after the dash giving us the min yield requirement, which is 50,000. There are numerous grades out there designed to meet the specific needs of the end use. Whether you need strength, flexibility, something hard, or a little bit of each, there's a grade out there designed for your end use. So far, we've covered sheet and plate pretty well. Now it's time to raise the bar and talk about long products. Rounds, squares, angles, channels, hexes or pipe, and tubing in multiple shapes. All of these materials make up the universe that is long product. First things first, what's the difference between pipe and tube? They both got a hole in it, looks pretty similar. Well, tubing holds things up. Think about the structural sections in between the aisles in a grocery store that go all the way to the roof, whereas pipe holds things in. Think of those irrigation units out in the field that you see when you're driving through on the interstate. Those things come to mind. We don't always actually see all the end uses for pipe because they tend to be underground or behind walls. One other way to quickly differentiate the two is how we talk about thickness. In tubing, we measure the size according to the OD, or outside diameter, and the wall thickness, the thickness that the metal is formed into the tube. So a common size would be something like 2-inch OD with a 1/4-inch wall. Whereas in pipe, we measure that with the term schedule. For example, a 1-inch, schedule 40, 1 inch being the diameter of the pipe, and schedule 40 being a designated wall thickness based on OD and ID calculation. Bars and structural shapes are the other side of the long product, and we separate those products into two main categories. MBQ, or merchant bar quality, is like the hot roll of long product, or, back to food analogy, like a simple bar of chocolate. Recipe may be a little bit basic, but it serves many different purposes. MBQ is hot rolled bar or structural shapes like angles, beams, and channels, and it is used in applications that don't need tight chemical, mechanical, or dimensional tolerances. This group of products serve a wide variety of end uses: construction, bridge and highway work, structural support, just to name a few. Now, as we move into the world of SBQ, or special bar quality, think of this like your Snickers bar. It builds off the basic chocolate bar, but its makeup is more complex. It has different ingredients to suit the different needs of the end use. SBQ bars are engineered for very specific applications, sometimes called engineered bars. These applications have tight tolerances, demanding chemistries, and mechanical properties that merchant bar just can't hit. Key end uses for SBQ include drive shafts for automobiles and boats, gears, bearings, and aerospace applications. Now that we've explored the world of carbon steel, from flat products, plate, a little bit of grade discussion, and a trip through the long products universe, what are some of the key takeaways? Steel is primarily made up of iron with a mix of other elements to make it strong, hard, flexible, whatever we may need. Flat products start as coil and become a sheet of plate. And tube hold things up, and pipe holds things in.
All right, cake and chocolate bars. That was a real treat, Brian. We have a pop quiz for you now, so if you'll participate on the poll. What is the name of the treatment for applications where thinner gauges and tighter tolerances are needed? And just while we're answering the question, Ryerson is a leading provider of both hot roll flat and long products. We have a variety of processing, so whether it's cutting to length sheet, flame cutting or plasma cutting plate, or saw cutting, laser cutting tube, or drilling holes in bars, we can do a variety of processes to those bars that Brian was just talking about. Then also, I know we had a couple of questions in the chat about when this will be available. This should be on our YouTube channel by Friday. All right, it looks like most people voted for cold roll, and that is the correct answer. Brian, if you want to share a little bit more about that.
Sure. Cold roll is a process in steelmaking where we take a pickled and oil coil and it runs through a certain set of mills inside, where you basically have 5 to 7 stands of work rolls that drive surface conditioning rolls. And so you can start with a thicker product that has a pretty wide tolerance of thickness. And then as it works through these rolls, there's a cold reduction process that takes place, and you can get down from, say, starting anywhere from 1/4 to 3/16 of an inch down to things that we would consider pretty thin. So you can get down to as thin as 0.019 or even maybe a little thinner. So as you engage in that cold reduction process, all of the tolerances tighten up, and the variation in thickness that you order is very minimal from there.
Thank you. And I believe we had a couple questions for you. So if the sheets are put into a bath, what happens if we use the galvanized sheets and then cut them with holes? Are the holes protected from rust?
There is some protection, but anytime you do any kind of process with galvanized, I think at the point of any kind of laser cutting or when you separate that steel, you're going to have the potential for some contamination. But it's not something that's of a major concern. Usually, if you run a piece of galvanized through a machine where you have you put a hole in it to have screws and washers, those things help protect that point where the metal is cut.
Then we also had 1-inch scheduled pipe is not actually 1-inch OD. Is that correct?
That is correct. And I'm not a pipe expert, but the actual OD of that is going to be a little bit more than 1 inch, and we can get some more information to you later if we need to clarify that. But yes, good question.
And then what about the reduction process is cold? Is it because it's done at room temperature?
Yes, exactly. So that's a great way to describe it. The coils come out of that pickle bath and acid, and they have to cool for a number of days. So you want those at room temperature because you're going to set those through those work rolls, and it is going to be room ambient temperature, yes.
And then which type of steel is best for bending purposes?
Well, that will depend on how severe of a bend you need and then how it's going to go into the end product. So, I mean, there are a number of things that we can do to steel to make it more flexible and have it take a bend, but it really just depends on the end use and what kind of bend you're going to have.
Awesome. And then I think we had one more. Is galvanized steel weldable?
It is weldable, yes. Unfortunately, I'm not a welding expert, so I can't say what types of welding would be best used in that application, but it is a weldable steel.
Awesome. And if we didn't get to your question, we will follow up afterwards. So we're going to be moving on to our next class, which is aluminum. So Professor Mooney, please take it away.
Hi, thank you, Chelsea. My name is Mark Mooney. I'm an aluminum product manager in the southeast part of Ryerson. Today, we're going to be talking about the fundamentals of aluminum, and we're going to talk about the nomenclature. So how do you call it out? How do you describe it in a way that is going to give it exactly the kind of properties that your customer is going to need to make it work? So with that, let's jump right in. So first, we're going to review the characteristics of aluminum, what makes it what it is. So, interestingly enough, aluminum, let's go back for just a moment. Aluminum comes from bauxite, which is one of the most abundant elements in the crust of the earth. Roughly, aluminum is about a third of the weight of steel. It is highly recyclable. And some fun facts from the Aluminum Association, 65% of aluminum is currently being recycled. On average, Americans recycle about 2 out of every 3 aluminum cans that they use. So yay us. And about 75% of all aluminum ever produced in history is still in use. So let's move on from there. So here we're talking about the characteristics of aluminum. So is it corrosion resistant? Yes, it is. It does very well in the elements. It's got a very high strength to weight ratio. More and more auto applications are being designed around aluminum for the lightweight characteristics of it, as well as the high strength characteristics of it. Excellent thermal conductivity. Aluminum is used as a heat sink to help carry heat away from its source, which is a very desirable feature. And then lastly, we've got a picture of a car and a can on here. Those are two of the biggest industry segments for aluminum. And in fact, we've got 3 new aluminum mills being built right now in the United States that are largely designed around automotive and beverage can production. So really big new key markets for aluminum. So what are the different forms it's available in? I mean, there's a wide range, obviously. Plate forms are typically, structural in nature. You might think of like a fuel tank for a truck or something along those lines. Sheet forms are, a little bit lighter applications. So that might be cosmetic. It could be a building fascia or something along those lines. Structural shapes like angles, pipes, channels, all used for structural applications. Bar is typically machined into smaller sizes, smaller diameters. And then the last one are extruded shapes. Many times we'll get an extrusion that's in a near net shape of what the customer is ultimately going to use. And what that does is it allows them to, or it saves them quite a bit of time on the machining because it's already in the shape that they're, or it's very close to the shape that they're going to be using. So let's move on. So we're going to dive into the numbers here. There's a lot of numbers around aluminum that really help narrow down exactly what the properties are supposed to be like. But for the purposes of this conversation, we're going to focus on heat treatable and non-heat treatable alloys. So the idea here is you're probably not going to remember all of this, but at least you're going to be familiar with some of the call outs. We're going to help you sound like an engineer, or maybe a little bit more appropriately, be able to understand what an engineer is talking about when they're describing the material that they're looking for. So let's get into the numbers and break that down. So this series is all non-heat treatable aluminum. So 1000, 3000, 5000 series. So I'll direct your attention to the first number in the series. That's the one that tells what the aluminum is alloyed with and how that can change the properties of it to more closely align with what your customer is looking for. So just real quick, the 1000 series is 99% commercially pure. That's going to be very soft and formable. So typically people are forming it. 3000 series, they're adding manganese to the mix. That's going to make it a little bit harder, a little bit stronger than a 1000 series. Excellent workability. 3003 is a common call out you might hear with that. 5000 series are adding magnesium, which is going to make it a little bit harder. In fact, the strongest of the non-heat treatable varieties. So that might be used for, again, a fuel tank or, signs or anything along those lines. So next we're going to get into the heat treat alloys. So these alloys, and you can think of them as you go down the chart, from 2 to 6 to 7, the material gets stronger. So 2000 series typically used in aerospace. They're adding copper to it. It's going to have better fatigue properties than 7000 series will. If someone's looking for that, they're going to tell you exactly what they're looking for and make sure and get it from them because it's probably got a critical application. 6000 series, we're adding silicon and magnesium. This is used for semiconductor manufacturing equipment, just a wide range of things. 7000 series, we're going to add zinc and copper. Again, and that's the highest strength in any of the aluminum families that we're going to have out there. Higher strength typically means lower formability. So let's get into tempers. So today we're going to discuss 5 tempers, some of their sub-designations, and then we'll dive in a little bit more into strain hardening. So thinking about temper, you can consider a paper clip as an example. This is, something that's pretty easy to bend and work around. One of the ways that they strengthen aluminum is by strain hardening it or work hardening it. So if we bend this paper clip back and forth, it's eventually going to break, right? So you can make it so hard that it actually becomes brittle, even like glass, as an example, is very hard. So hardness doesn't necessarily mean strength. It just ultimately, changes the properties of it and, to make it better for certain applications. So here we're talking about temper. We've got the group up here. F is as fabricated. They're really not doing very much to that. O temper is annealed, so it's going to be very soft, very formable. Strain hardened is like our paper clip we just talked about. They're reducing the thickness of it. They're work hardening it to give it the properties that they're looking for. T is thermally heat treated, so they're using heat to make it harder. And W is solution treated. Don't see that one too often, but really that one has to do with age hardening. And the mills actually have a process in place where they can actually facilitate that, make it happen just a little bit faster. So next we're going to get into some of the detail on the strain hardening tempers. 3 different tempers here, and really what you want to keep in mind. H1, no thermal treatment. It's primarily hardened by cold working. H2 and H3 both get strain hardened, so they're work hardened, but they're also partially annealed, which is going to make it a little bit more workable. So each of these calls out some very specific practices at the mill that are going to help them to produce the aluminum in the way that's going to meet your customers' needs. So several variations of strain hardening, and what I really want you to look at here is the last number in the sequence. So HX2 is 1/4 hard, HX4 half, 3/4 for HX6, and full hard for HX8. There is an HX9 that's extra, but we don't see that so often. Really what you want to look at and pay attention to here is that last number. That's going to define how hard the material is. All right, now we're going to go into grade anatomy. So this is common grades, and we're going to talk about the tempers a little bit. So a little bit more nomenclature. Okay, so this is showing you a couple of different alloys out here. I should have Chelsea's pop quiz right here to see if everybody remembers what the ingredients are, but we're showing a 3 series and a 5000 series here. That first digit, again, recognizing what alloys are added to the mix to make it, to put it into a family of aluminum. Each of the other numbers, I'm not going to get too far into this, but I'll tell you that it further refines what the properties of that aluminum are. So they just denote a different variation in that family. So 3003 is a very common one. And as an example, 3105 might be, a slightly different version in that same series. Both of them alloyed with manganese, but both of them a little bit different tempers or a little bit different properties that are used in different applications. So 5000 series 5052 would probably be your most common one. And another one that you might see is 5005. So again, both of them alloyed with magnesium, but a little bit different properties just depending on what the end user's application is. So next we're going to get into heat treated. So here we're pulling it all together for you. The 6061 T6 designates the alloy as 6061. T6 is the temper because it's got a T in it. It's thermally heat treated, and because it's got a 6, it's 3/4 hard. So that gives you some background on just how that would look and how that comes together. So from here we're going to talk about finishes. Lots of different finishes on aluminum. We just kind of had to pick some of the most common and popular ones, but the first one you see down there in the truck is a buffed finish. That's similar to a polished finish, but they're buffing it with cloth wheels instead of with abrasive sandpaper. Obviously, it's also available in primed or painted. If you've got someone looking for painted, it's not just as easy as saying, give me white aluminum sheet. You've got to spell out the manufacturer of the paint, how thick it has to be. Do you paint it on one side or 2 sides? There's generally a paint spec that goes along with a paint call out. So be sure to look for that if you see that coming across your desk. Finishes, again, anodized is similar to painted, but it's kind of a metallic look. I'm sure you've seen it. I can't think of a great example of it, but it's got a really cool, you see it a lot on cars and that kind of thing. It's a very metallic and be blue or green or pink or whatever you can think of. A dog tag would be a great example of an anodized aluminum part. tread plate, you see that commonly on emergency vehicles, fire trucks, ambulances. It's that raised diamond pattern. Gives a little bit of traction to it, but frankly, a lot of times it's just used more for decorative. It's highly durable and very very popular finish. Then embossed, we get into they're actually rolling a pattern into the aluminum. Typically, it's stucco or diamond or leather grain feature, and like the photo shows up there, a walk-in cooler would be a great example of that. You put your fingers across and it's got kind of a coarse feel to it. It's a little bit rigidized, perforated and expanded, or a couple of other options out there as well. Okay, key takeaways. Aluminum is an abundant metallic chemical element. We talked about the different forms of aluminum. We talked about heat treatable and non-heat treatable products. Let's see, and then 5 different tempers. And then there's 9 different aluminum finishes. So bonus points for anybody that can name all of those in the quiz.
All right, now it's time for our aluminum pop quiz. So which of the following is not an aluminum temper designation? Annealed, strain hardened, thermally heat treated, or anodized? And Ryerson can offer custom extrusions. So the way that works is we would create a cross section that would fit much closer to the final shape. So if you're doing a lot of machining on aluminum round or flat bars, it's a great opportunity to save a little bit of weight and reduce your amount of machining time. So it's a great opportunity to be a little bit more efficient. We could definitely talk to you about that after the presentation as well. So we'll have a little bit more time for the pop quiz. And our answer was anodized. Anodized is one of our finishes and not the temper designation. All right, and then I think we have some questions for Mark about what we've gone over. So we'll start with the first one that I have. Is aluminum infinitely recyclable?
Yes.
Yes, so make
Not
sure
a lot of
you're
color behind that, but yes, it's super recycled. So I mean, like we were talking about with the Aluminum Association just a moment ago, 2 out of every 3 beverage cans are recycled, and it's crazy recyclable.
put your cans in your recycling. We need them. So on that note, where is aluminum mined?
All over the world. I mean, the bauxite comes from all over, and I mean, a lot of it, like, as you just mentioned, is recycled. So, they take the recycled chips or leftover pieces of sheet metal or cars or whatnot, and segregate it and throw it all in the big pot and recycle it.
And then what is the difference between aluminum plate and aluminum sheet?
Thickness. Once it gets up over 1/4 of an inch in aluminum, we start calling that plate, and sheet is 249 and lighter.
And then we know we talked about tempers a little bit. So is 6061 T6 a generic name that would include 6061 T6511?
They are a little bit different. T6511 is typically called out on extrusions. T6 is typically more for plate.
And then can you explain the difference between aluminum and aluminized?
Aluminized is a kind of steel, whereas aluminum is a completely different animal. Aluminum is 1/3 of the weight of steel. So they're going to use that where, weight characteristics are really important, but also cost quite a bit more. So it's not necessarily going to be a cost savings, but like a vehicle manufacturer that's looking to make cars lighter so that they can get better fuel efficiency, aluminum's a great option for them.
And then one more, we'll do what are the largest end uses by market for aluminum?
Well, I guess a few of them. What's driving activity at the mills right now, a lot is aerospace type applications. So people making airplanes and, that type of thing. Military components is a very big end market for aluminum. Can is a big one that's even just continuing to grow. More and more people are, wanting to use aluminum as opposed to plastic because it can be recycled. Boy, just anything under the sun. Signs, there's just lots of different industry segments out there.
Thank you so much. And if we didn't get to your question, we will be following up afterwards. So we'll be getting with you after on those. And then we're on to our last class of the day, which is stainless steel. So Professor Gomez, would you please enlighten us?
Good afternoon, everyone. My name is Angie Gomez. I'm a product specialist based in California. So today we're going to spend some time learning what makes stainless steel and its different grades, what forms it comes in, and the different finishes or looks that stainless can have. So let's just jump right into it. What is stainless steel? Well, stainless steel is an iron alloy that starts with iron and carbon as its foundation, just like carbon steel. But to be considered stainless steel, the chemical makeup must be composed of at least 10.5% chromium and less than 1.2% carbon. So the other two main elements found within the stainless families are nickel and molybdenum, or moly. With 5 families of stainless steel available, each is differentiated by its alloying elements that are added. There's over 150 different stainless steel grades, each with their own chemical makeups. However, we usually only see about 15 grades like commonly used. Stainless steel is considered corrosion resistant. This is due to the fact that because of its chromium content, it is continuously protected by a passive layer of chromium oxide that forms naturally on the surface when the metal comes into contact with air or water. This layer of chromium oxide allows the stainless to regenerate itself if scratched, thus making it corrosion resistant. Stainless steel comes in many forms and shapes, just like the other metals we discussed today, so let's go take a look. You can buy stainless as flat product, which includes sheets, plates, and coils, just like carbon and aluminum. We also buy our stainless bars that come in many shapes, including round, square, and hexagonal. Also available are angles and structural shapes like I-beams. You might be familiar with pipe and tube, most commonly ordered as round, square, and rectangular. So now that we've gone over some of the basics, let's jump a little bit deeper into the stainless grade families. There's 5 families of stainless steel that's classified by their grain structure. Each grain is achieved by adding the elements that we mentioned earlier in specific amounts. 2 of those grain structures are austenitic and ferritic. You're more likely to be familiar with these, so we'll start there. Austenitic stainless starts our journey, and these are typically seen as 2 and 3 series stainless grades. 201, 304, 316, for example. You can see on the slide that these grades are highly weldable, they're ductile, and they can resist high temperatures. Austenitic alloys contain a higher percentage of nickel and chromium, and also the addition of austenite. If you see an L, for example, 304L on a test report or stenciled on any material you might have received, that means it has a low carbon content, composing less than 0.03 of its chemistry. You see austenitic metals used for food containers, tanks, silos. Most general purpose and cosmetic applications will use this. Next, we can go into the ferritics. So these are going to be your 4 series, 409, 430 are probably most common. Ferritic stainlesses have low weldability, moderate ductility, and they maintain a high temperature resistance. Ferritic stainlesses contain more chromium than the austenitics we just talked about. They don't have any nickel, and then they add in ferrite. The absence of nickel allows ferritic stainlesses to be more stable in pricing over time. Ferritics are magnetic, while austenitics are not, because the austenitics contain austenite. Ferritics are used in appliances, car exhaust systems, and dishware. You can find 430 as the interior walls of your washing machines, and 409 usually will make up your car exhaust systems. Next, we can go to some less common stainless grades, and you can take a moment to see the differences between them there. We do have access to these more specialty grades and can provide more in-depth information if you believe your application might require them. I'll touch on them just briefly. So martensitics can be used in cutlery and tools, and they contain a higher chromium level than austenitics and no nickel. Duplexes are common in the oil and gas industries due to offering properties from both the austenitic and the ferritic grades, like weldability and being highly formable. You may have heard of 2205 duplex, and duplex actually got its name because of its dual grain structure, which is composed of both austenitic and ferritic structures. Oil drilling and water treatment operations use duplex a lot because it's actually stronger than 316 and better at corrosion resistance. Precipitation hardened, also known as pH grade, is actually a hardening process and less about its chemistry. It's a heat treating technique which is used to increase the tensile strength of the material. These materials are usually found in aerospace and high-tech applications like gears, valves, and other engine components. So let's switch gears and discuss how stainless looks once it's produced. But before we do that, let's watch a quick video to recap some of these chemical compositions.
304.
316.
304.
316.
Oh boy, I've heard this argument before. Which stainless steel is better? Well, that all depends on your application. You see, both 304 and 316 hold similar properties due to the alloying elements used to create these grades. But let me tell you a secret. 316 is a bit more corrosion resistant. That's due to the presence of molybdenum. Now that's hard to say. Let's just call it moly for short. 316 is in the austenitic family of stainless. It contains anywhere from 2 to 7% of moly, which is higher than that contained in 304. The higher the moly, the higher the corrosion resistance. You know, moly is what they call a ferrite former. That means that when it's added to improve the corrosion resistance of an austenitic stainless steel, there must be an austenite former such as nickel or nitrogen that is added in order to keep the structure austenitic. Sorry, I tend to really geek out with this kind of stuff. Okay, so back to the question. If your application requires a high level of resistance to corrosion, let's say a chemical processing or marine application, then 316 could be a better fit. So, hopefully, that gives you some guidance on which may be best suited for your application.
All right. So I hope that really helped drive it all home. Now we're going to talk about the finishes that stainless can have. So the first finish we're going to talk about is a hot roll finish. It's also known as number 1 or HRAP. HRAP stands for hot rolled, annealed, and pickled. This is a dull, non-reflective finish. We mostly see this finish used in industrial applications that doesn't have any cosmetic needs. This finish can be seen on most of our CMP and PMP products, which is plate. So anything like 3/8 and over. We do get into it in the 1/4 inch, but that can kind of go a number of different directions. So the next finish we'll talk about is actually a cold roll finish known as number 2D or just 2D. It's also a dull, non-reflective finish, but it's a little bit smoother than HRAP that we previously discussed. It'll go through a descaling process. And we typically see this finish used in deep drying applications where some lubricant retention may be needed. To the eye, it's going to have a real dull gray appearance, but it's not going to have any scale on it like the HRAP does. The next finish is probably the most commonly used and found finish of stainless steel. I'm sure most of you have seen it, even if you've never worked with it. It's the 2B finish. This is a cold roll finish, slightly reflective, perfect for most general purpose applications that doesn't need any kind of like reflective properties. The next finish is BA or bright annealed. This is also a cold roll finish. The appearance of a BA finish is almost mirror-like. We see this finish used in a lot in the transportation sector. and it gets this shiny reflective appearance through an actual annealing process that's done while it's being produced at the mill. Next, we can look at the polished finishes. So number 3, number 4, these are also cold roll finishes, and they have either a full polish or semi-polished surface. And the metal achieves this polished appearance from the use of abrasives on its surface at the mill or the polishing house. While stainless steel is already corrosion resistant, when polished, that actually is enhanced because the smoother surface will actually not allow any like dirt or bacteria to stick to the surface, which might kind of eat away at it over time and cause that oxide to reform itself. So it just makes it a cleaner overall surface. Many industries use this polished product in like kitchenware, tanks, like the inside of wine tanks, just because of that quality. The last finish that we can talk about is rolled on. So this is actually used to mimic the number 4 finish we just talked about, but instead of using abrasives, the mills actually apply the finish with a press. So it allows for a more consistent finish, and a lot of appliance folks like to use this as well, just for consistency across product lines. So now I'll take you through some of the bar finishes you can get. So again, we'll start with the hot roll. So hot roll comes out of the mill similar to how carbon bar is produced. It doesn't get any extra processing done. When it comes out, it's kind of dark, oily, pretty scaly. So no, like, unless you don't care what it looks like as far as your finished product, it does usually have any like appearance applications. The next finishes, we can talk in kind of a group. They're all the cold finish processes. So centerless ground finish is a material that's ground to a very specific diameter, and its appearance after that grinding is going to be pretty shiny. Cold drawn it will be actually drawn through a die. It doesn't always have to be round bar, it can also be flat. And when it's done, it can be dark or shiny, but there's going to be no scale on it. So kind of similar to what we talked about before with the HRAP versus the 2D. So kind of a similar comparison there. Rough turned is pretty much just how it sounds. We're going to see this used in large diameter bars. The mill's going to rough turn it to kind of a diameter within some ASTM tolerances, and then it's going to be sold and usually finished to a very specific size at the end user. TG, or turned and ground, is exactly that. It's turned on a machine and ground down. Again, we see this process used to achieve a very specific diameter with tight tolerances. We'll likely see a shiny in appearance after it's done, and then we can jump right to TGP, so turned, ground, and polished. Same start as the turned and ground, but the final process will actually get some abrasives and some buffing to get a very shiny polish, reflective pretty much. So the last one we're going to talk about is actually the next slide here, and it's something that we offer called pit-free dairy. So pit-free dairy polishing is used to remove all imperfections to create a true, smooth, pit-free surface finish. Pit-free polishing is the perfect way to remove all the microscopic imperfections from material that's going to be used in like food or dairy applications. If you think your application could use pit-free dairy finish, reach out to your local sales reps for more information. But here's a little video to go into some more detail. So there we go, another cool product that Ryerson can provide. So now a little recap on everything we covered today. Remember, stainless must consist of a minimum of 10.5% chromium to be considered stainless. There are 5 families of stainless steel that each have their own chemistries and characteristics. Pit-free dairy polishing provides a consistent and quality finish that removes surface imperfections for food and dairy applications. We covered 6 flat finishes and 8 bar finishes that are typically used in stainless steel products. And with that, we'll go to Chelsea for some of your questions and hopefully answers.
All right, it's pop quiz time again. It's our last quiz of the day. What is the name of the stainless steel finish that helps achieve a non-reflective cold roll surface? And then while we're doing that, we have a fun fact for everyone. In 1926, Ryerson actually was the first stainless steel distributor, and that's just 2 years after the material was developed. So stainless steel is not quite 100 years old, or I guess it'll celebrate its 100th year next year. Happy birthday. I feel like we need Jeopardy music.
Right.
All right, Angie, take it away with our answer.
Yeah, so looks like there was a little split there between 2B, 2D. 2D is the correct answer. So 2B does have a slightly reflective finish. We mentioned it briefly in the slides there, but 2D is pretty much the hot roll finish with the descaling done. So no reflective finish on it. It's going to be very dull, kind of a smoky gray color on the surface. Where 2B, it's just going to have a better finish on top, and so it's going to just have a little bit of reflectivity on it. So I could see some confusion, but yes, 2D is going to be your right answer on this one.
Awesome. All right, and now we have some questions. So you touched on the lower carbon variant of austenitic stainless steel, so 304L, 316L. Do we work with any of the higher carbon variants, or do we mostly sell the dual cert material?
We can get higher carbon material. The markets, usually like dual cert or just kind of like standard grade. So we can get into kind of like the 304Hs, stuff like that. If you need it, it's something we definitely have access to. There's usually not much like cost variances involved. It's pretty much just asking the mill to stay within certain ranges of some of those chemical compositions that we talked about.
All right, and then we have a question: is A286 a form of stainless, or is it just a little bit corrosion resistant?
I saw that one pop up, and I wasn't too sure, so I was briefly trying to rack my brain, and it doesn't jump out to me as a stainless temper or like a spec. So I'm thinking that it's just going to have some corrosion resistance attached to it, but I can definitely circle back and do a little more in-depth research on that one. But it's not something like that I would commonly bring in or that we get a lot of hits on. So if it is a stainless grade, it's going to be or a temper call out, it's not going to be something that I've dealt with much.
Awesome. And then is 2B considered a mill finish?
That is, yes. So that's going to be the mill finish. If I don't give any kind of directions, that's what they're going to send me. So 2B is kind of the standard, the bread and butter, and then number 4 is probably right behind that as far as commonality goes.
Awesome. And then for number 3 and number 4 finish, what does that correspond to in terms of the grit?
Yeah, I was trying to look at that too. So as far as like the paper that's used, it can range anywhere. So as the RA finish, which is basically if you're looking at the surface of the material, when we talk about polishes, we get into what we call RA finishes, and it's basically the gaps between the peaks and the valleys of the surface finish of the material. So to get to the different finishes on top, so like a number 4, I think they typically would use like a 150 to a 180 grit abrasive sheet on it, and then when we get to like a number 4 or sorry, a number 8 finish, it gets up into like the 220s. So it just depends on what level of reflectivity and like mirror finish we're trying to get. And it gets progressively like more grit on it as we get to those levels. So it'll pass through multiple phases. So if we're taking a number 4 to a number 8, they're gonna progressively get those abrasive sheets on to get it there, and then they'll actually buff it, and then that's what's going to really take it to that mirror reflection.
Awesome, thank you. And then what series would 17.4 stainless fall under?
17.4 is we typically see that as our precipitation hardened grades. So those go through a special tempering process like we talked about to make it super strong. There's usually very specific applications for 17.4, and we definitely have access to it. We do see that market growing and staying pretty stable. So yeah, if you think you have some applications for some 17.4, we can definitely get you more information and also provide you material.
And then one last question, can you explain passivation for us?
Passivation, so that's going to be sending the sound waves through, it's kind of a very detailed thing here. So it's the chemical treatment that the stainless goes through, and it basically is what makes it really corrosion like resistant. So it's a treatment that goes across the surface to really seal up and give that stainless effect basically to the material. Yeah, it's kind of a very many like diagrams that go into this. So for that one, we can definitely provide some more in-depth information, but it's basically just the chemical treatment that the stainless goes through to make it corrosion resistant.
Awesome, thank you so much. And I want to thank everyone who joined us today for Metal 101. Hope you learned something in class. And now that you've completed the intro course, you're ready to move on to the next level. So we'll be having Metal 102 in the spring. We also have a past Metal 102 that you can check out on our YouTube playlist on the QR code on the screen. We'll also available at Ryerson.com. So if you have any questions about what we're stocking or what the nearest location is to you, definitely check us out at Ryerson.com. And another next level course you can take is our Cup of Joe. We do that monthly with our market risk management to learn a little bit more about what pricing is doing and what the metal market is. So our next Cup of Joe will be next week. So please scan the QR code on the screen if you'd like to sign up for that monthly podcast. And if we didn't get to your question, again, we'll follow up with you afterwards. We want to make sure that you're getting your questions answered, and we'd love to continue to improve this. So if you have any suggestions when the survey comes out, we'd love to hear them. But other than that, I appreciate y'all joining us. I hope you learned something, and thank you so much.